tell you a little bit about some new work we've been doing, thinking about how you actually might put aerosols in the stratosphere. The novel method we've been thinking about, or it's not novel at all, it's actually exactly what happens from aircraft contrails, is that we put a condensable, a few megatons a year of sulfur would be enough to produce sort of 4 watts per square meter radiative forcing directly out of the back of an aircraft. There's a huge literature in the nanofabrication world about making fine particles from low vapor pressure gas, and there's nothing very hard in terms of aircraft engineering. If you go to aircraft engineers, and we've done this, they say that would be easy, we could do this if you want us to. We've mostly thought about sulfur, and there's a lot of good reasons to think about sulfur, because sulfur's what nature does, at least in this version of the model, is if you put sulfur in continuously, you actually get a remarkably ineffective result. Nevertheless, there might be some good reasons to think about alumina. The big deal really is that alumina has 4 times the volumetric rate as sulfur, but roughly 16 times less the coagulation rate. So you could get away, we think, with much smaller mass flow. The little picture is from a nanofabrication study, which shows you can make high-quality alumina particles just by spraying alumina vapor out, which oxidizes. So it certainly seems pretty cost-effective and easy to do this with aircraft that are not very different from conventional aircraft. High-class business jets like the Gulfstream have wing designs that are very efficient. So with slightly different engine choices, they can easily deliver large weights up to sort of 20 kilometers or a little higher. And you could do that by either building new versions of these aircraft or even re-engineering existing aircraft. We have engineering firms that can do it. So you go to an engineering firm and you want this done. They don't say this is hard or unusual. They say, okay, yes, we could do it. Once you realize you can make things by direct condensation from vapor, then all sorts of different compounds are possible. But it's much, much harder to actually figure out the environmental risks and effectiveness of these new methods than it is to cook them up. Aerosol geoengineering looks like it is so cheap that the cost is basically not going to be an issue. That means that implementation decisions will be risk-to-risk decisions. So the key factors are this is fast, it's cheap, and it's inherently imperfect. It cannot compensate for the amount of CO2 in the air. On a commercial basis, I do absolutely no proprietary commercial work on solar radiation management because I think such work would be wrong.